So we're going to have two more sessions here on tissue sampling. Steve is going to go next and kind of give us his perspective, and then I'll follow it up with mine. There's just a lot that I feel like everybody has a different perspective about tissue sampling and kind of where that's going. It's not clear. It's not cut and dried. I think that's one of the main takeaways that we're learning. It's not an exact science. There's a lot of variables involved in tissue sampling, and so I think the more perspectives we have on it, the better. And really, it comes down to drawing conclusions on your own farm and on your own set of data and what that looks like. So, with that, we'll let Steve take over.
All right, thank you. You're letting me back up here again, so that's good. No other choice. All right, so Tim had a discussion around looking at this yield component of tissue analysis and really trying to identify that. I'm going to spend my segment of this talk discussing those components and what have we learned by trying to assess it to yield. Now, I'm a huge advocate of looking at yield on an individual plant basis to develop understanding about what's going on in your field. So this segment is going to discuss this individual plant fraction and how tissue results are being assessed when we look at it as an individual plant basis. So I've titled this Tactical Tissue Testing. I believe that you should have a very specific purpose and agenda when you go out to do something. If you go out and you tissue sample and you don't have an objective, you're going to have a lot of questions and probably very few answers. So when we set out to look at this tissue testing protocol, we wanted to answer some key questions. And the key question that I had was, is there a correlation to yield as it relates to tissue analysis? And we started this concept of this ABC tissue testing. Did anybody do the ABC tissue analysis in here? Okay, for those of you that may or may not have seen this, this was something that we thought was going to help provide some value around what are your plants doing and are these tissue results going to help us predict something? So I'm going to share those. I want to start off again with the slide that I left on the last discussion, and I want to point out that V6, V7 rapid growth stage, because this is what I think the takeaway is going to be on our tissue results. So from my previous presentation, we discussed this average yield, and I have this broken out into these groups. So that same 39 plants that we referenced, what the tissue ranking was. So an A plant we classified as a really standout plant. A B plant was an average plant, and a C plant was the weakest plant in our sample group. So that's really what this relates to. And I went and categorized the plants by that tissue grouping. So you can see that A plants, we had very high yield per acre. B plants, we were in that 250 type range, 260, 275. And the C plants, we were down around 150. Now that should lend itself to something in the tissue results. And I think it does. It's just interpreting them appropriately. Here it is on the individual plant basis. These A plants grouped together, they averaged that 0.6 of a pound. The B plants were right around 0.4, and the C plants were 0.2. This is the same information that I showed you before, just classifying it by the plants and how we went through this ABC testing protocol. And here's the results. So you can see this blue line, and this is the growers that we had collected that did ABC. This is the nitrogen line across the A plants, the B plants, and the C plants, the potassium, and the phosphorus. What stands out to you? They're what? They're all the same, right? Why? Why are they all the same? yet they had a different yield. What is the difference between this plant and this plant? It's bigger. What does bigger mean? It weighs more, right? It's got more biomass, more plant material. And this has been my challenge to the laboratory. When I test it on a percentage basis, how do you think the laboratory takes that sample? They take the same amount of tissue and they process it. If I have a bigger plant that has 3.5, 3.6% nitrogen, does that plant have more nitrogen as a whole compared to this plant that maybe is half its size? Yes, it does. But this is also why it makes tissue testing a challenge to relate it to yield, because if we don't understand the biomass, if we don't know how big the plants are, it's hard to draw that to some yield. But what I think we're identifying here is that we really need to look at this as an individual plant, and this is my opinion. I want to understand the individual plants, the uniformity, and are we achieving these levels of sufficiency like what we're talking about? Can we define those numbers to achieve that 0.6 of a pound of grain? And these A plants, what did they achieve? They achieved 0.6 of a pound. And perhaps maybe the information is right there in front of us. Maybe we need to do a better job of defining our plants. Here it is with calcium, magnesium, and sulfur, and you see the same response. In fact, we see a little bit higher percentage in those weakest plants because there is less plant material. Here's the micronutrients that we tested. You can see we are getting the same thing. Copper, we've got iron, we've got zinc and boron. They're all stacked up and they all look pretty similar. And then this is by the development stage. And this to me was fairly exciting when we looked at this grouping of these plants, and this is a little bit hard to read, but here's the A plants. So that would be this blue line here. And we've got the A of phosphorus, and then there's a gray line here that's the A of potassium. And you can see how all of those plants relate as they go through this growth stage. What stands out to you? And this, again, is the average of the growers that we had in this. Back to that nutrient uptake chart. And I had to standardize this, okay? So this is this V6 growth stage. V6, V7, what's happening? Our nutrient levels are falling off dramatically, and then they kind of level off, and then we're probably making some applications here and seeing a little bit of a response, or are those particular plants maybe aren't moving as much into the grain, so they're retaining more in the vegetation, and that's what you can see here later in life as we look at these plants that maybe aren't producing as much yield, have a lower tissue or a higher tissue concentration because there's less being translocated to the grain. But this to me was the big takeaway. Knowing how much nutrition we need to get the plant to make sure that it has enough nutrition to get it through that rapid growth stage. And I think this is where we need to focus. I mean, I think we are shorting this. When you think about 400 bushel corn and you're talking about needing 12 pounds per day per acre of nitrogen and potassium, that's a lot of nutrition. Multiply that out over this 30-day window that it's going to rapidly grow. We have to ensure that we have that out there. And I've often joked about how we typically fertilize. It's like feeding our plant Thanksgiving dinner, and then we hope it's going to be there when we need it. Because we do a lot of fall fertilization, a lot of nutrients placed out there. What's happening to those nutrients in the soil. Are they there? Well, that probably depends on your soil texture. If you have a high clay content soil, do you have more nutrient availability or less nutrient availability than a sand? You can hold more. You can hold a lot more. Doesn't mean it's available. So these textures are going to make a big difference. Your soil pH is going to be a huge player. Those are the things that we need to be focused on when we assess these tissue results. Not just this yield component, but understanding what's going on in that plant's life and what does it need. Can we drive those values higher? My one contention with that, did we produce our target yield under this tissue sampling protocol? Did we get the results that we wanted? Did we achieve our target yield? I'll back up. What was our yield goal? 400 bushel. Did those plants hit 400 bushel? Yeah, they did. What was the problem? I didn't have enough of them. I didn't have enough of those plants. I had too many of these plants. I had a nice amount of these B plants, but if I were to give you a distribution, and I had 15% of my plants that are A, and 20% of my plants that are C, because of how uniformly they emerged, then my yield at the end is something that I can predict. And that's what I think we need to be able to do. Can we continue to assess those plants that are going to produce our top yield, the plants that are going to give us our lowest yield, and these average plants, what are they going to give us? Again, this is 1 year's worth of information. I had a colleague of mine that would always say that research is like having a flashlight. It gives you some direction. Doesn't mean that it's right. Okay, so these are just indications. If you're in a dark cave, which is what I liken farming to, you want to have a flashlight. Okay, we want to have some guidance. And I believe that this tissue testing, I've argued round and round about what I think we should be looking at. I'm really not changing my tune. I think we should be looking at this from an individual plant perspective and figuring out how to get more uniform plants. Here we're looking at, this is an individual grower's data set. Okay, so this was the whole, this is an individual grower's data set. This ended up being 317 or 312 bushel corn for his NCGA check. And you can see this drop-off that occurs. So our goal for our fertility program is to ensure that we have enough nutrition. And I've been telling him that what we've been doing is producing a 200 bushel stock and trying to get a 400 bushel ear. Well, that doesn't work. We need to make sure that we're producing all 400 bushel plants. And I think we've got the right ingredients to be able to feed it. Now, are we cost effective? I don't know. We kind of threw the kitchen sink at it this year, and that probably wasn't the thing to do. And what did we miss? We missed analyzing our stand to know what the yield was going to be at the end. And so if we can do that at the beginning, then I think we can properly feed it. And these guys that are hitting these huge yield numbers, they are adamant about having uniformity. I didn't quite understand it, how critical it was, until this year I started capturing the data around it. And I've also got some pretty interesting stuff around soybeans. And if you were to ask me which crop is it more critical to have uniformity in, I'd tell you soybeans. Because the denser you plant a crop, the more uniformity you need. And that's what we're seeing in corn. And we're seeing the same exact thing in soybeans. We have a huge distribution that's occurring in these plants in terms of their pods. So our keys for next year are to focus our fertility plan around this rapid growth stage. And my struggle with tissue testing is, when is it giving you an indication of your nutrient values? After they've already been assimilated into the plant, right? So we're already behind. So I'm a huge advocate of understanding the nutrient uptake. How much are we going to stick into the stalks and leaves and the grain? And building a plan around that. Because if we get behind, which is what this data shows, we just got behind here. We were on a downward slide and we couldn't catch it. And it was also because we didn't know what we were doing. I mean, we just were like, oh, we're capturing some information. What's this tell us? And now we've taken it back, and then we've taken it back to this yield. And we've got plants that are awesome, plants that are not so awesome. And we have this indication that really shows maybe as a whole, we should have had more fertility up front near the planting time to make sure that we didn't short the crop at that V6, V7 time frame. So this is exciting stuff. I've done tissue testing a long time, and this was the first time where I felt like we actually had some information that was putting some teeth into this deal, where you could take it back and assess the plant and what the plant was doing. And back to this biomass component, that's why we need to quantify these plants. We need to put some framework around an individual plant so that we can develop a sufficiency range. Because I'm not going to change the laboratory's mind about testing for the total biomass of the plant. We need to understand that. And there's probably influences from hybrids and timing of sampling and all of these other things. But this, to me, was a step in the right direction. And I hope that I can encourage you that one thing that we didn't do a very good job of at the end of the year was taking the yield of those individual plants. Because that, to me, is the critical component to showcase what tissue tests are actually correlating back to. A tissue sample is the average of one plant or a few plants, right? It is not the average of an acre. It is of a single plant or maybe 10 plants. And if you group the same 10 plants of similar characteristics, I think we will start to uncover a lot of things. So that's my rendition of this tissue sampling. Again, our program that we're moving to on our farm and the growers that I'm working with around fertility are to ensure that we have enough nutrition up front to set the stage. And that might mean we're putting it through the drip system. We're just doing it earlier because I think we've been behind. You know, I tell my guys, we're getting ready to ramp up. We turn it on. I think we were 2 to 3 weeks behind where we needed to be. 2 to 3 weeks is in a potassium uptake is over 200 pounds in a big corn crop. That's a huge number. And when I started to look at the stalks and what was happening, you know, that was probably where we were really missing the boat. So I'm hoping that next year we can continue on. I can convince a few more of you to maybe do this, and we'll keep trying to uncover this tissue puzzle. Anybody have any questions? Yes, sir. When did we start adding fertilizer? We started adding fertilizer at this V6, V7 time frame. But the problem was we didn't have enough out there when it needed it. No, but it has to be in the soil water. The nutrient uptake occurs in the water. So if it's not in the soil water and ready to be taken up as that plant is rapidly growing, the plant's root system, the root hairs are viable for 2 to 3, maybe 4 days, depending on the soil-air ratio, that oxygen component. So we were, why I think we are getting this spike later, this is when uptake occurred. The plant doesn't have a regulatory mechanism, really. I mean, it's just taking up the water. There's a few exchanges that are occurring, but mean, as a whole, we were on this downward slide and then we bumped up. Why did we bump up? We started to take up the nutrition that we were applying, but we were behind. We created this deficit. And no different than irrigation. If you are in a deficit irrigation scenario, are you going to optimize yield? You're going to be behind, right? Because that's how much water you have access to. It's no different with nutrition. If you are in a nutrition deficit, and that slide that I had of one of our farms that had the yield variability, it was in a nutrient deficit. And that happens in all of our fields. I mean, we have variability that occurs. I just think we have to be a lot earlier. We need to bump our calendar up for when we start applying. And that's one of the advantages that I like about drip, is that I can start to put the nutrients out there in small doses of water and keep that profile full. So if we do catch a rain or something, we're not going to diminish what we've got in the soil water.
How much delay is there between when you apply a nitrate type of nitrogen fertilizer to when it's available to the plant? Is it immediate, or is there a time delay that you have to anticipate for the microbes in the soil to make that available to the plant?
Nitrate is immediate plant food. Okay, so is ammonium, NH4 or NO3 being nitrate. The difference and what we don't know, so this nitrification that occurs, this conversion from ammonium to nitrate with bacteria, that's a whole different process. When we put that in the soil water, the key is you have to have enough air and water to maintain root growth. And one of the big questions that we haven't answered this, but what is the electrical conductivity and the pH of the water? And are we getting adequate root growth? And are we getting adequate uptake? And there's a whole host of questions. I felt like in some of our examples, we weren't getting uptake as rapidly as I would have liked to see. And that may have been because we were overwatering in that instance. That air-water ratio is a pretty important component. And so if it's in the soil water and you have roots, the roots can take it up if the roots are viable. So that depends on the distance that you have to migrate water. Where are the roots, and are they actively consuming water and nutrition? So if the nutrition's in the water, assuming the total dissolved solids are low enough that it'll take it up and not scare the plant to death, which is, I think you can put too much in at one time. Those are the factors. I don't have an answer. It could be, for nitrate, it could be, a week. For potassium, it might take us 3 weeks. Those are the things that we're trying to address and uncover.
If you put it in at noon, it's not available at 1 o'clock.
Correct.
Okay, so
In my opinion.
There is a time delay of a week or 2 weeks between when you put it in and when it's available.
From what we have seen thus far, yes. Or from what I have seen. I shouldn't throw everyone in. Maybe Tim can elaborate. I don't know. When I'm just kind of a crude scientist, all right? I'm an observationist. I like to live out in the field and look at what's going on out there. And then I try to understand it through pieces of information. And when I see this, and I know when we started to put fertility on, and I see this spike of all of these nutrients, of nitrogen, phosphorus, and potassium across all of our plant types, that makes me think maybe we didn't have it out there when it needed it. Or maybe we needed to achieve a critical concentration for it to take it up. I mean, back to the clay versus the sand concept, it's a lot easier to take nutrients out of sand than it is to take it out of clay. Clay is going to hold it. Sand is not. And when I pay attention to the guys that are producing the 500 plus bushel corn, I want to know how to raise 500 bushel corn. And they put on a lot of nitrogen, and they put on a lot of phosphorus, and they put on a lot of potassium, and they're trying to achieve that yield trajectory. They also are big on uniformity. I'm not reinventing the wheel, maybe just trying to do it in a colder, more northern latitude. But raising plants really has the same basic ingredients. I mean, you've got to have sunlight, CO2, water. Then you have to have your nutrients. And we are battling our soils to have available nutrition. Nitrate is an anion in the soil, so it leaches. That's what everyone's talking about, negatively charged. So it's going to stay in the soil water, assuming you don't push it out the bottom. So there's a whole host of complex things, but there's cool sensors that will allow us to measure fertility. I think we can really start to refine our fertility programs in irrigation with some of these tools. Yes, sir.
You started at V6?
So we turned on our water and our fertility. We had front loaded our fertility. Okay, so in this example of this grower, we used anhydrous, we had banded nutrients, and we had done some starter. And so this was where we were living. We were up here actually in our earliest test, which was V3.
You were thinking you started sooner then?
Yes.
What stage are you thinking?
So we turned it on at V6. We were already on a downward slide.
Right.
One of these other things that I have a question of is, did we just hit our band of nutrients that we had applied at that point in time? Yeah.
So where are you thinking you're going to start? You're going to try and start then?
I'm going to turn it on about when the corn plant's about this big.
Okay, that's what I'm doing.
Yes. And I'm going to give it nutrition because in our experience, we want to use the tool to fertigate, not necessarily to irrigate. So we are trying to get more upfront nutrition, whether that's through our planters and our other fertilizer tools or through our irrigation system. I mean, that's the goal. And I might come back next year if I get invited back, and we might have a different result, right? That's the goal. Like, if we keep those numbers up there and we achieve uniformity of emergence, which is the first thing that we have to do. I'm not even going to turn this on if we don't have uniformity of emergence. We're not even going to, because this year I cost this guy a lot of money because I'm like, yep, we're going to throw the kitchen sink at it. But it was a great experience because we got to learn what that did for us. And when we had the right plants, we achieved target yield. If we can create all the right plants, then we need to apply the nutrition at the right time. And there's all kinds of discussion around forms and factors. And I mean, we're doing lots of stuff around the fertility side of things. I just think it has to be earlier. The number one phone call that I got as an agronomist at Pioneer was around a corn plant transitioning from seed to nodal roots, which happens around this V4, V5 stage. It goes away from feeding off the seed and starts feeding from the soil. What happens at that stage to your cornfields? They get what? They get a little yellow, they get a little uneven. They get a little variable. We cannot have that. That is not acceptable. And you know what I told everybody in that experience? Oh, it'll grow out of it, and your yield will be fine. And guess what? Your yield was fine to what we expected our yield to be. So if we're expecting our yield to be 200 bushel, for example, then that is acceptable. You can raise 200 bushel corn and have that variability. You cannot have that and raise 400 bushel corn. And I think you can have that variability and you can raise 300 bushel corn because we're doing it. We are doing that. You know, we are raising 250, 60, 290, 300 bushel corn, which is great. But when I start to think about these systems and what they will allow us to do, you know, I kind of set my sights high. I'm like, 400 bushel corn is where we need to live, and then we need to live at 500 bushel corn. And I think we can do it if we follow these rules. If we don't, you're not going to get the benefit. It's just that simple. Yes, sir.
This guy's field, how much fertility before soil fertility before we use nutrition for
So the question was, how is the fertility of this field before we started to irrigate? I would say this is an average field. We kind of disregarded our soil tests in this experience because I have a hard time quantifying what your soil is going to do, which is why when I work in a sand environment versus a silt versus a clay, sand is easier to predict what will be available, assuming you don't drive all the water out. So we didn't even pay attention to that, which could be the wrong thing to do, because this balance thing, there's some other, I could show you more slides. I know everybody loves charts and graphs, but looking at the nitrogen and potassium, and the guys that were hitting the top yields had the best ratio of nitrogen to potassium. And then when we had lower yields, we would widen our nitrogen and our potassium would be lower. So that's a trend. Doesn't mean it's done right. So in this example, fertility is just what I would say is normal. I mean, if you talk to David Hula or ask him about his fertility levels, sand doesn't hold very much. So when they reference their fertility levels, they're not like what our fertility levels are. I mean, we've got more stuff in the soil. It doesn't mean it's all there and available when we want it to be. And we have to keep that in mind. I mean, there can be, you can have 400 or 500 parts per million potassium and not have enough plant available K to raise the yields that you want.